Okay, on to question 4. On the first question on question 4 wants us to state the term exothermic. So if we actually look at the parts of that word, so exo means out, so that means we're going to get a release or giving out of, well, thermic refers to heat energy, so essentially a reaction that releases or gives out heat energy. Okay, so just to put that, so a reaction that releases or gives out heat energy. On to B, so which of these diagrams shows the electronic configuration of a fluorine atom? Well, if we look at the periodic table, fluorine has 9 electrons, so they'd be arranged like this, so be 2 in the first shell, and then the other 7 in the second shell. So we're looking for a diagram where we've got 2 electrons in the first shell and 7 in the second shell. And A is the one that matches that configuration. On to C, so we're looking for the charge of a sodium ion. Now, if we look back to the atom, to form an ion, sodium would lose this 1 electron. So if it loses an electron, that means it will become positively charged, because electrons are negative, and if you lose something negative, that overall makes the ion more positive. So we can immediately discount A and D because they both have negative charges. Now we've only lost 1 electron, so that would mean that the charge would be +1. So that puts C out of contention, and that means the correct answer is B. So finally, we've got a longer question where we have to explain in terms of structure and bonding why sodium fluoride has a high melting point. So important just to note that we need to be talking about ionic bonding here, because we've got sodium fluoride, an ionic compound made of a metal and a non-metal. So first point is the 2 ions would form this sort of structure, which we refer to as a giant ionic lattice. So that'll be the first mark. You can see each of these ions is joined together by strong ionic bonds. And we also need to describe what those ionic bonds are between. So we can see they're between 2 ions of opposite charge. So we've got a negative ion here and a positive ion here. So between ions of opposite charge. So we get our second mark for stating that the ionic bonds are strong, and the third mark for saying that the bonds are between ions of opposite charge. And the final fourth mark comes from stating that, well, if the bonds are strong, it's going to require lots of energy, and we must use that word energy to overcome the bonds.